Everyone. My name is Karen Cameron, CEO of the Ontario Public Transit Association, and it's my absolute pleasure to welcome you to this Opta Live webinar. Opta, the Ontario Public Transit Association, is pleased to be partnering with AECOM and BetterFleet to bring you this 1-hour webinar on electrifying transit in Canada. With that, I'm going to turn it over to Holly Montalban.
Hello, and thank you, Karen, and to everyone at the Ontario Public Transit Association for all that you do for transit and providing educational resources like this one for the industry. We are proud to be Opta members and to be here with you all today. So welcome everyone to our webinar on electrifying transit in Canada with experts from AECOM and BetterFleet. I'm Holly Montalban, Marketing Director at BetterFleet, and I'll be moderating the webinar today. If you have questions at any point throughout the webinar, you can put them in the chat. This says the Q&A box, but it is just the good old chat box for this Zoom meeting. So you can see that icon at the bottom of your screen. You can go ahead and put as many questions as you'd like into there, and we will address what we can at the end of the webinar. And if we aren't able to address your question on the line today, we're happy to follow up with you via email afterwards, and we will also share some contact information with you at the end. So let's go ahead and dive right in and take a look at the agenda. First, we're going to hear a quick overview from AECOM with VP of Government Relations and Transit Market Sector Lead, Kirsten Watson. Then we'll hear from Sasha Pezhik, North America Managing Partner at BetterFleet, for a brief intro. And then we'll dive into some top challenges fleets are currently facing in the journey to zero-emission technologies, starting with moving from planning to action, which we'll look at with AVP and Transportation Market Sector Leader Amin Sadeghi, then moving into managing energy demand and costs with Mike Bismeyer, North America Director of Sales and Client Solutions at BetterFleet. And finally, we'll hear about fire safety for electric bus fleets with Fire Protection Engineer from AECOM, Chris Fike. We'll plan to have about 45 minutes for the presentation and 15 for Q&A at the end. And with that, let's kick things off with Kirsten Watson, VP of Government Relations at AECOM, to tell us a little bit about AECOM.
Thanks, Holly. I'll be brief. Thank you, everyone, for attending today. It is so great to see so many people interested in the topic. And of course, thanks to BetterFleet for partnering with us on this webinar. Thanks, Karen and Opta. And I also want to do a shout out to the Thermal Events Task Force. They met with us, I guess, last week and gave us some really good feedback. So thank you for that. So next slide, please, Holly. So just a little bit about AECOM. We're end-to-end provider around ZEB fleet transitions, service planning, schedule impact analysis, alternative delivery. That's the contract models, you know, P3, some of the collaborative models. We are heavily into program management to help agencies with complex programs. And I think our differentiator around program management is that we have actually delivered infrastructure. So we know the challenges. Facility engineering and design, you'll hear from Amin today on that. And of course, technology and our digital systems integration. Next slide, please. So where are we? AECOM is across Canada, working with many of the people on this call actually on various fleet transitions and implementations, feasibility studies, and charging infrastructure.
Gosh.
Next slide, please. I love that response. And we are, of course, in the United States, and you'll hear from Chris, who works in our U.S. business across 50 transit agencies, of course, and he'll speak to some of the challenges and some of the work that we are doing with those agencies. So we bring a real depth of experience to this discussion and to AV transition generally, EV transition. Next slide, please. I'm going to pass it over to Sasha.
To Kirsten, yeah.
You're on mute, Sasha.
Well, look at that. Yeah, thank you, Kirsten. I just wanted to echo a lot of the same comments. Thanks to Opta. Thank you for everyone for joining today. We are very, very excited to be here, and obviously, talk about our collaboration with AECOM, which has been wonderful. Next slide, please. So just very briefly about BetterFleet. We are a global company, founded in 2016. Our singular mission is to decarbonize fleets. That's all we do. We've worked with over 200 fleets across the world in all market segments. And really the platforms and the things that we've developed, and we'll talk about a little bit today, is really been designed with a lot of research and development. We're very big on grants and looking at things, complex challenges that we can solve collaboratively with our clients through grant funding and things like that. So really everything we've built has been in collaboration with our clients and with their insights. So certainly a very powerful combination. Next slide. So very briefly, a singular platform to manage and plan complex zero-emission fleets. So obviously our focus today is on the bus side, but also our platform is adaptable to other fleets. If you're looking at non-revenue vehicles, paratransit, or even broader municipal vehicles, sometimes we end up working in partnership with transit and municipal, where there's a shared fleet manager. But essentially, two components from our platform: planning, implementation, and operations. First, looking at how you plan your transition to zero-emission fleets. So we've automated the process of being able to analyze your routes, your schedules, your blocks, to be able to identify, yes, we'll be successful in electrification or not. We're able then to also visualize how the vehicles move through the facility, and whether a vehicle comes back from being out in service and what that looks like, and whether it can go back into service before charging or not. And also just understanding all the energy requirements, both on the battery electric and hydrogen side. From a management perspective, really, that charge management aspect, being able to monitor the performance of your fleet, understanding, kilowatts per kilometer and things like that, taking control of your chargers and being able to turn on and turn off those chargers and manage them. And Mike will talk to you a little bit about that. And really just looking at other advanced aspects, such as understanding what the estimated range of that vehicle will be for this day based on historic and based on weather predictions and things like that. So last, a powerful collaboration between our two companies, AECOM and BetterFleet. Not only are we working together in Canada, the US, but we do work together globally. And we've worked, we've teamed up here. We've worked on several projects, both in Canada, some that even Kirsten mentioned, in Saskatoon and Brandon, Manitoba, and some things here locally. But also many different projects in the US, working with DDOT Detroit on their bus work and such. But essentially, the partnership and the collaboration we've formed is really to be able to drive kind of the end-to-end solution. So with their expertise and experience in infrastructure, ours on the software side, we really do have something that's quite powerful and quite data rich. So with that, I will turn it over to, I don't know.
Thank you, Sasha. No worries, I'll take it from here. So now we're going to go ahead and dig into one of the top challenges fleets are facing in the transition to zero emissions, and that's moving from planning to action. So we have AVP and Transportation Market Sector Leader at AECOM, Amin Sadeghi, with us to share some insights on this topic. Amin, over to you.
Thank you, Holly. Good afternoon, ladies and gentlemen. And I would like to echo what Kirsten and Sasha just mentioned, thanking Opta and all of the transit agencies and my peers who attended this call. Next slide, please. I just wanted to mention that none of our approach to design could have been possible without our wonderful clients who tell us what they want, and we talk about some of the details and challenges and they had, and especially to the dedicated team that I have the privilege of working with at AECOM, who know that I don't take no for an answer, and results is what drives us to build a better world. So talking about battery electrical buses has been going on for a number of years, but I mean, the perception of a battery electrical bus has been different from region to region. Some regions love it, some regions like it, some regions don't like it at all, and have totally gone down the path of stopping it. But in order to reduce our carbon footprint, we really need to go down the path of decarbonization. And what better than reducing our carbon footprint in transit, what we do on a daily basis. Next one, please. Next slide. So we do understand in the engineering and the architectural field here today in North America that there is not really an approved standard or an enforced code for the design of indoor battery electrical bus garages. There are some standards, one which we saw from Opta a couple of weeks ago, which was really, really interesting to read, and basically showed me and my team that we were on the right approach. There are some European guidelines for the design of similar type of facilities. And of course, we have the OBC, the NBC, other provincial codes and state codes in the United States, and of course, NFPA regarding some fireworks. Before we start digging in, I just wanted to mention one other thing, that this approach is not standard, it's not code, it's what we have come up with through discussions with our clients, and there could be better ways of designing, I mean, with the information possible maybe in the future. And the next item that I should mention is that our approach was based on a new facility and not existing. So next slide, please. So how are diesel bus garages designed today? We know, those who have worked within them, those who have designed them, that these are open space facilities. And one of the main features of them is that for exiting, we are using perimeter exiting around the building for life and fire safety. So the buses are parked very close to each other, maybe 3 or 4 feet, allowing people to pass through them and get to the bus or exit the facility. Next. Now, we've heard through conversations with clients, with insurance companies, and some of our own internal staff, and you will hear from Chris later on, that the ignition point of battery electrical buses kind of require them to be a little bit at a distance from each other. How much that is, we don't know, but right now, I mean, it hasn't been confirmed, not that we don't know, or we have some numbers, but it's not confirmed yet because it's not written in the code or a standard. But if we design to those numbers, the length and width of these kind of facilities, large facilities, is going to be somewhere around 400 or 500 meters in length and width, and we can't have that. So speaking with some of our clients, insurance companies, they have come and told us that they can live with a reduced number of batches of buses at a distance from each other, separated. Great. Now, going through some of the documentation that we went through and speaking with, again, internally and externally, we thought that putting in firewalls that would separate these batches can somehow reduce our risks. Now, these firewalls would be designed in a way that each, let's call it, cells are going to be sustainable if they catch fire. Next slide, please. And if they catch fire, the fire would not pass through the wall and damage the next cell. 2 hours was the minimum that we talked about, but with the height of the structure, we will achieve more than 2 hours, and that goes back to the materials that we're using. Now, each of these cells, as I mentioned, are going to be structurally independent. So if there is fire, the fire services cannot go into the cell and retract the bus, and there is a possibility of a collapse of the roof, which we are going to fire rate to give more time. But at the end of the day, if the roof collapses, what we are going to have is not the collapse and the destruction of the whole building. Next slide, please. So this approach made us start thinking again. Going back to that original design of garages, what we have is an open building with exits on the side. With these firewalls, we can't have that. Although some would argue that going from one firewall through to the next cell, you are within another building. However, we started to think about how much we can reduce the risk. So by introducing exit path along in between some of the cells, we could safely exit our staff. Now, these exits are going to be planned in location that would basically respond to our needs. But then again, we were thinking, next slide, please. We were thinking, it's not only about the buses. We have other things that we need to think about as well, things that could burn. So what we are seeing in some of the bus garages now that have added pantographs or other means of charging is that the electrical equipment are right there beside the bus or the charger. Now, if there's a fire, we're going to lose those electrical panels as well. So we started thinking, we have this long corridor, which is tall because of the size of the building. What could we do to use that space? So some of our team came up with this idea that having a service corridor above the exit corridor is going to allow us to place all of those electrical equipment inside the service corridor, and they're all separated by a fire barrier. Next slide, please. And then we were thinking, okay, what else can we start saving? Generally speaking, we have our HVAC system and any other mechanical equipment right on top of the roof. So if the roof collapses, next slide. If there's a fire, the roof will collapse, and next slide. And we will be losing those mechanical units too. So if we can place those mechanical units on top of the service structure, then we are maintaining those equipment throughout the damage that possibly would be or would not be there. So basically, we've designed a service space where everything else other than the bus, which has caught fire, is going to be safeguarded. Thank you very much.
Thank you, Amin. Much appreciated. With that, we're going to shift gears a little bit to focus on managing energy demand and costs with North America Director of Sales and Client Solutions for BetterFleet, Mike Bismeyer. Mike, take it away.
Thanks, Holly, and thanks, Amin. Great job as always. Again, echoing everybody else, thanks to the Opta and all the participants. There's never a time in transit where we're not busy, so we appreciate you definitely joining us. And just on that realm, thanks. It is Transit Operator and Worker Appreciation Week, so just thanks for all you do, because we all wouldn't be here if it wasn't for what you're all doing every day. So much appreciated. So yeah. So real quick, when we start to talk about managing energy, obviously there's different political environments that are sort of pushing transition initiatives in every scenario, and regardless of the propulsion that's chosen, the energy cost factor is a huge part of the ROI. And so having the tools in place to make sure that that's being managed and operationally tested and proven out is key. reacting to the grid in real time, understanding from the utility partnership that your transition plan isn't the only one that they're probably planning for. So understanding the impact that your requirements are going to have on the grid, as well as those around you, some of the municipal fleets, some of the other folks that are also caught in this. Obviously, it all has a determining factor, and having tools in place that allow you to sort of pivot to real-time market factors and different changing scenarios and to test those out. Obviously, part of that whole planning, the electricity costs and sort of the energy demand, and we'll talk a bit about that more on the next 2 slides. But a big part of that is understanding not just what you're doing now, but really what is the need going to be when we transition that entire fleet, because most likely the utility is also going through that same phased approach and sort of having to plan all that out too. So those are key, and it's all part of that implementing the right energy strategy for sure, and understanding what that's going to look like. So next slide, Holly, for sure. So when we talk about the planning aspect, there's a bunch of different things that go into it, but really it comes down to having the right tools. And you're going to hear me say it over and over, but having planning and planning again, because it changes as much as a lot of these agencies that are on the phone. A lot of you are thought leaders and have had done your original fleet transition plans, and we know that a lot of things happen, right? So the technology continues to change. There's different iterations. We're seeing some OEM uncertainty in different market spaces, not so much in Canada, but a little more in the US, where those can all affect plans, and you need to have those tools to be able to rerun scenarios, rerun ideas to build out accurate budgets. So from the energy standpoint, obviously understanding just what is going to be the total need to start with, and having tools that can allow you to run your own analysis to understand that. But then really quickly seeing what is going to be the impact of that need, managed versus unmanaged. It can be quite substantial, and we can all be hit with those first energy bills, which are a big surprise. But having tools that allow you to optimize a couple different things, right? So different scenarios with different OEMs, where you look at strategies with more onboard energy versus more opportunity charging, different charging scenarios in the garages, different types of charging scenarios based on maybe the location of where your garages are and the available energy. The other thing that we would stress is that, having the ability to run simulated models of what it's even going to look like and prove it out. Is it going to work before we start that construction and getting into even some of that design concept? So that's again where we've had partnerships with AECOM, and they've used some of our planning tools in the background to sort of look at some of those strategies as we're planning out garages. But definitely, sort of emulate your vision and understand if it's actually going to work. Integration with different softwares and what effect that's going to have as well. So next slide, Holly. Thanks. So ultimately, when you get to the point of implementing charge management, the key to all of this is having the ability to react in real time, really is what it is. And so whether that's different grid signals, maybe that's different things that are going on at particular sites, having multiple sites where you have different rules. So you're managing energy based on different scenarios. Maybe there's backup energy storage on one side, maybe there's solar at another. Being able to integrate that with your charge management software and understand what is going to be the impact operationally. There may be scenarios where you run out plans and for instance, and it says, your modeling shows at one particular location, you need 6 megawatts, for example. And the utility says, well, it's going to be a while before we get there. You're only going to have 4 megawatts, for instance, for a certain amount of time. So being able to manage that load across your fleet and having tools that allow you to manage even right down to the dispenser level on different rules and different scenarios is quite crucial. Optimizing different things such as dispatch integration. So, having a software that allows you to do more predictive things, where maybe a bus comes in and at any one given time, as it's going through its charging cycle, you can hover over that particular bus and maybe it'll show you the routes that it would currently match up to without having to go to 100%. So again, optimizing sort of the available energy, sort of leveling that out. We've also done some studies with some entities sort of globally and in North America. We're just starting a new one where, sort of like we're looking at the ability to have our charge management software react real time. So you would want to look at that too, like from different market signals. So maybe the utilities, we'll look at California, for instance, where they have rolling blackouts or different rules, or they have excess energy they're trying to dump off at different times. And how does your CMS react with that? And how does that parlay back to the different sites that you're managing. So that's key as well. Definitely the overall having the right charge management software or the tools in place anyway will allow you to get real-time information all the time to validate things such as utility bills, and understand really what's happening every day, understanding those charge cycles on the vehicles and how that impacts the battery warranties, those sorts of things. But ultimately, the bottom line is when it comes to energy, having a management tool in place to sort of cost appreciate it right from day one. A lot of people ask, when is the right time to have charge management software? I'd say you're all thought leaders that are on this call. So if you're doing electric vehicles of any sort, I would say have charge management software and start using those tools from the get-go, because it also holistically works on the change management internally and championing with folks. Obviously, everyone here probably has multiple teams and departments, from planning to dispatch to operations to IT, that all have different requirements. So starting that process early and having a tool that will allow you to sort of organically grow as you implement more vehicles as well. So yeah, and I can tell you that one of the questions we get asked quite often is, what is the cost net difference of having charge management software? Typically, if you have the right software in place or tools, you can validate that cost right away by saving. Not having to use one charger or saving on one utility bill is pretty quick return on investment. So thanks, Holly.
Great. Thank you, Mike. Good stuff. And also just a reminder for everyone on the line, if you have any questions, you can submit them through the chat. You can send them to everybody there in the chat box, or you can just send them directly to me. So thanks to a couple of people who sent me questions. And we will get to Q&A soon. So last but not least, we'll talk about a topic that has increasingly risen to the forefront of industry discussions, and that is fire safety for electric bus fleets. We have touched on this a bit already, thanks to Amin, but we're going to have Chris Fike, fire protection engineer at AECOM, go a little bit deeper. So Chris, thanks for joining. I will hand it over to you.
Appreciate it. Good afternoon. I wanted to thank everyone for taking the time for tuning in and continuing a conversation I believe many transit agencies are having around how to protect their people, their facilities, their assets, and also the first responder community. Next slide, please. So when starting any project, regardless of the scope, I always recommend performing a fire hazard analysis to evaluate how what we're planning on building or modifying will impact the employees, their operations, and facilities. An FHA is especially important when dealing with technologies that are developing as quickly as battery technologies, which we've seen have had documented failures. While our codes and standards writers are updating their documents based on the available information they have, the process does take time, and it's not always keep up with rapid evolving technologies like we see with battery energy storage. So with that being said, I do recommend referring to documents like NFPA 551, which is the guide for the evaluation of fire risk assessments, as well as Society of Fire Protection Engineers guide for risk assessments. When developing and reviewing FHAs, as well as the most current codes and standards, and then outlining the requirements for battery systems. NFPA 55, which is the standard for the installation of stationary energy storage systems, and as well as the International Fire Code here in the States, are updating the requirements based on all the new research available. But while BEBs are not stationary systems, the guidelines outlined by these committees can be evaluated for guidance for potential mitigations. Also, standards like UL 9540 and 9540A are helpful to understand what testing and evaluation options are available for energy storage systems. So when we're left with gaps in outlining the minimum requirements in adopting codes and standards, we start to look at performance-based design approaches in determining the minimum level of safety to achieve the safety goals for the different stakeholders that are involved. Performance-based design starts similar to any other design with a hazard analysis, but specifically when reviewing hazards associated with battery technology and specifically BEBs, we need to evaluate what's being done throughout the industry by other transit agencies, testing labs, and even the equipment manufacturers themselves. Once we've evaluated our inputs to the hazard analysis, we can then complete the fire modeling necessary to determine what an event would look like in a specific facility, and then how it will impact all the adjacent assets. After we've evaluated and agreed on what a baseline model would look like, then we can evaluate the different combinations of mitigations to determine their effectiveness to achieve those stakeholder goals that we talked about earlier. Next slide, please. So while we're starting to see data that is leaning towards EVs that are safer per mile driven relative to internal combustion engine vehicles, failures involving batteries can be catastrophic. So typical failure modes that we see include mechanical damage, which could be caused by an impact such as a en-route accident. Electrical damage we can see from over or undercharging of batteries, could be associated with non-UL listed batteries or chargers. And then manufacturer defects, which are rare but difficult to find and detect. And then heat exposure, which could be due to something similar to a battery cooling system failing or other support system failing. Next slide, please. In the end, BEV is largely the same as an internal combustion engine vehicle, in that it has large quantities of traditional combustibles. These combustibles are the tires, the seats, the foams, the plastics, and we've studied how to control and extinguish these materials for years. The transition to BEVs does create a new hazard with the addition of the onboard batteries and the high voltage power systems. And when these batteries fail, they are multidimensional fires and they're difficult to extinguish. To extinguish a fire, we need to be able to remove one of the three legs of the fire triangle, either it's fuel, oxygen, or heat. And we can't remove the fuel since the battery electric leg itself is flammable. And testing has shown that smothering a battery fire to starve it of oxygen is not effective when applying an agent like a dry chemical powder, which leaves us with cooling the fire as our best means of being able to control these fires. Next slide, please. To evaluate different mitigations, we first need to develop what different facility types will be housing BEVs and what will the buses be doing in these different environments. And also critical in the early stages of the hazard analysis is to determine what are the performance goals of the mitigations, such as protecting building structure and determining what is an acceptable loss so that mitigations can be designed and tested in the models. Determining what an acceptable loss is a difficult question to answer. It's going to take a lot of input from multiple stakeholders to determine an answer. Every client is going to have a different level of risk tolerance, which will influence how facilities and the systems are designed to limit the impact of an event. Facility mitigations for consideration will be different for each client and potentially each facility. Should include combinations of mitigations like ensuring correct sprinkler density, smoke detection, ventilation, passive fire barriers, even structural fireproofing. Next slide, please. So as with most fire protection schemes, multiple layers of mitigations are going to be important. The hierarchy of mitigations in facilities starts with the telematics that are coming from the buses themselves. I feel like this is going to be one of the most important means of stopping the catastrophic failure before they happen, but it's going to benefit from a lot of interagency information sharing to determine what are the correct factors to correlate to successfully identify a thermal runaway event, and then be able to reduce false alarm impacting bus operations. There's going to be a tremendous amount of bus or information coming off of these buses, but then being able to understand and then escalating any key variations in performance from these data streams will allow intervention early on in the process, which will increase our ability to be able to reduce the event's impact. If battery management systems fail to stop the thermal runaway event, then building protection systems are our next layer of protection. Some options include starting with smoke detection, which will provide early fire department response and occupant evacuation. Also ensuring that suppression capable of preventing fire spread from asset to asset and impacting the building structure is provided. And then also providing manual smoke and heat removal systems to aid in fire department response. One note on ventilation, it's important to consider ensuring that the ventilation systems don't activate too early in a fire event, which may delay the activation of sprinkler heads, causing the fire event to actually grow. So then lastly, these are going to be long duration events. We're going to need first responder support. So it's important we work with our first responders to ensure we're giving them the tools that they need to be able to effectively and as safely as possible perform their operations. Access to water is going to be critical for any response. So working with the first responders early on in the project, it might become apparent that something like an investment in a non-code required fire standpipe system in certain areas of a facility could significantly improve the fire department's ability to respond to the fire. So as I mentioned before, it's important to ensure and understand that every client and facility will be unique. please don't take these thoughts as the only way that these hazards can be addressed. Clear and detailed conversations at the beginning of each project is going to pay dividends through the life of the project, and ensure that whatever solutions are designed, meet the different needs of the different stakeholders. Thanks everybody for your time.
Great, thank you, Chris. Great overview. And now we're going to move into the Q&A, and we've had some questions come in throughout the webinar, but you can certainly go ahead and put more questions in there into the chat while we're going through them. We'll try to answer as many as we can, and we can always connect with you over email as well. So you do have some contact information here. And so let's go ahead and start with the first question. So I will turn this question over to Mike Bismeyer, and it's, do e-bus manufacturers provide CMS?
Yeah, so great question. So typically most of the e-bus manufacturers will have some sort of in-house product, either that's sort of tied to their diagnostics, or perhaps they've partnered with a particular sort of charger OEM on the deployment that you're doing. I will say that we're seeing more and more agencies start to ask questions about, or to look at using someone that's agnostic. So, in our scenario, we are agnostic. We'll work with any OEM. And really the reason behind that sometimes is when you're looking to share some information or to try and have that one source of truth, you can run into some interoperability or integration desires from competing OEMs on sharing certain things. So a perfect example on what Chris was just talking about, if there's a desire to integrate other alerts into the CMS platform, and one of the questions we get asked all the time is exactly the battery thermal temperature alert. Obviously one OEM might be a little reluctant to share it into another OEM software. So more looking at that agnostic CMS that sits above it. But I would say that most, we've partnered with all the OEMs out there on different deals, as have other CMS providers, but typically they would have some sort of offering, or at least guide you in a direction for sure.
Great. And while I have you on camera, Mike, I'll ask you one more question that came in here, which is, how does your charge management system integrate and prioritize bus charging and charge levels for sequential chargers?
Yeah, great question. So again, we're seeing on different sites with different charger OEMs. So everybody, similar to when everybody says they meet the OCCP standards, everybody has said they can do either sequential or simultaneous charging. Typically, we're seeing that it's a hardware design implementation first. So to make sure you get the right design put in. So sequential charger can only do sequential charging, whereas we've seen the OEMs that have simultaneous can do both sequential and simultaneous. And in both those scenarios, we can manage power right down to the charger level based on rules that would be put into the CMS when we go through a scope of work discovery with you. So we can manage right down to the dispenser level in both scenarios, so sequential and simultaneous charging. Hope that helps.
Perfect. Thank you, Mike. So we've got a couple fire-related questions coming in. I was waiting for them. So now we've got those questions here. So I'm going to ask to either Chris or Amin, are there current stats on the frequency of battery fire incident events across North America for ZEBs?
I can take that one. So we're starting to see a bigger population of data that is, relative to, we have a ton of information over years on internal combustion vehicles. So we're starting to see reports come in, and as the data population comes bigger, we can rely on it a little bit more. I know NTSB, something that they're tracking here in the States, but we're also seeing just independent studies pop up as well. So a couple different data sources out there. And I think as we start seeing the information come in and the data set grow, we'll start seeing a little bit more reliability and the people standing behind those stats.
Yeah, and it looks like we've got Mike Mackis from TTC putting in some more information into the chat. So thank you for that, Mike. Much appreciated. And we've got another question here that you might be able to take for us, Chris. So that's, do you see smoke detection as an effective early detection method? It says many bus OEMs are offering their battery packs in a sealed system, and gas release wouldn't be detectable until flames or heat have caused the pack to fail and it's already in an advanced stage of fire. So any thoughts you can share on that one, Chris?
Sure. So it's important to think about what are onboard mitigations and what are facility protection mitigations. So once the pack has gone into that, I agree that once you start seeing smoke out of the pack, the event is well underway. At that point, what you're trying to do is protect the facility and then come up with mitigations to limit that thermal event to that bus only. Ideally, your battery management system would be able to isolate those arrays, take them offline, send warnings to be able to get the bus out of the facility. It's the steps after that happens and any of those initial operational procedures don't work that you'd you'd have facility protections so smoke detection is one way to take a look and see if the cost of installing area smoke detection in a facility would bring to the left of the response. So would increase your ability to detect the event earlier on in the fire curve process rather than later. If you can save 5, 6, 7 minutes in response time, being able to get the fire department there and operating sooner, based on the facility arrangement, that's when area smoke detection would be a benefit to look into. It's all going to come down to cost, and whether that provides a benefit to be able to kick off other types of mitigations and being able to get people out of the buildings sooner. But agreed that it's not going to be as beneficial as an onboard solution.
Great. Thank you for that one. So the next one, we'll see. I'm not sure if this one's going to be for you, Chris, or for Amin, but the question is, it was mentioned that STM in Montreal has illuminated some challenges related to converting ICE depots to support BEVs. Can you provide any high-level comments or lessons learned from STM's experience? So I'm not sure if they haven't exactly explained the challenges. Okay, great. Thanks, Amin.
So just going back to the last question for a minute. So one of the things that we have discussed with our clients is that monitoring of the buses should be in place and understanding where the bus would hit that thermal runaway point. And if the bus has reached that point, it should not come into the garage at all and should be sent to the quarantine zone. However, we do understand that, that situation could happen at a later date while the bus is within the garage. And that's why we have taken the precautions that we have. Now, going back to existing facilities, and namely what STM has faced, similar to many other clients, the challenges is that, first of all, size of the building has been one of the many things that I have heard regarding existing facilities. The size of pantographs don't match. The separation could not be placed within the garage. And one other thing is the fire separations. I mean, if a client wants to go down the path of following what we presented, they can simply not put in a firewall because a firewall has, some requirements. So those are the challenges. Fortunately or unfortunately, I don't have any projects that are within an existing facility. The ones that we have are either new or they are an addition to an existing facility. But thinking about the situations of what could happen inside an existing facility, makes me tired. I mean, it's something that we need to address sometime because we have assets, 50, 60, $100 million worth of buildings, and we need to be able to use them. But to be continued by our team or peers.
And there's a follow-up question here that you might be able to help with as well. And it's regarding the discussion with insurance underwriters and firewalls. Would that be an alternative to wet sprinkler systems or a preferred method?
Well, it depends on the insurance companies. I mean, from the firewall point of view, I mean, what we're trying to do is to reduce the risk to the overall fleet. And but I guess yes, the answer is yes. Chris?
I don't know if I'd consider it to be a substitute. Looking at how to solve each in particular problem is going to be, it's going to take just conversations between, again, insurance companies are most certainly going to be in that conversation, but I wouldn't say you're going to be able to replace sprinklers with the use of firewalls. It'll definitely be an added benefit if the facility layout can support that. But also, everything comes down to cost and what is the return on investment to be able to put in some of those different mitigations. So it all plays into one large response and overall system approach to how you're going to protect the facility and then all the assets inside that facility.
Mm-hmm. No silver bullet or one size fits all, as is typically the case. I'm going to move to a question that somebody sent to me directly here, and this one I'm going to address over to Sasha. And the question is, what type of integrations are needed when implementing a charge management system?
Yeah, thanks, Holly. I mean, it really depends on ultimately the end client's desires, but we do typically see different types of integrations being requested. Looking at things like your dispatch system, or looking at what you're using currently with yard management, that comes up often, but then also looking at planning and scheduling systems. So really the complexity depends on the end customer's desires and goals. We see that often, just in terms of us deploying, let's say, our solution, we do have to sometimes integrate with whatever charger is on site. Many of them we've already pre-integrated, so that's not really a roadblock since we've done that, but it just really depends on what's being desired and what systems. We see some really bespoke stuff popping up. And the thing to really consider there is, how complex do we want to get in that integration? I mean, as a software company, we can integrate with whomever. That's not a problem as long as they have an API available. But I guess the question is, how complex do we want to get? And then realizing that there's a cost driver to that in that level of complexity. So just understanding kind of that tipping point, understanding how far we want to go in the integration. But those are some of the common things we see.
Great. Thank you, Sasha. And the next question that we have here is, are there any public transport that use bus preconditioning? Mike, is this one you want to take?
Sure. Yeah, absolutely. So yeah, again, similar to, the charger manufacturers all sort of having a different way of, or a different interpretation of the standards that they meet. We see this also on the preconditioning side. I have some experience on this with one OEM that I worked with at a certain amount of time, but every OEM handles this a bit different. But yeah, typically they're all, the requirement is there for all of them to do it. Whether they're compliant or not is sort of still up for debate. But I know yesterday for instance, we were on a shortlist bid call where there is a requirement based on the OEM for a compliancy to 15118, which is a charging protocol to do with, so it's ISO 15118 to do with preconditioning. And we were asked to make sure that we could support that, which we do as long as the OEM does again. But yeah, absolutely. It's a requirement we're seeing on a lot of the CMS RFPs. Where the CMS can control the preconditioning scenario for the agency. But again, it's OEM dependent, same as some of the other signals that they're sending off. But yeah, absolutely. Great question.
Great. Thanks, Mike. One more that just got sent to me, and this one I'm going to ask to Amin since it's related to his presentation. You mentioned that there are not fire codes for buildings regarding, BEBs yet in the garage. Do you see that developing and changing soon? Is this something that's in active discussion that you're aware of?
Well, I truly hope so. We are speaking with a number of, building departments where, we have projects. And we are speaking with some code consultants, because at the end of the day, it's I mean, design of these facilities are also related to life of people. So we hope that by advocating, as consultants, as client groups, we should be updating all of the building codes, at least in Canada, and hopefully in the States. I'm not sure what's going on in Europe right now, but hopefully they're following the same path.
Mm-hmm. And Chris, if there's anything you want to add to that, definitely feel free. And I'll also punt the next one over to you, which is, can infrared temperature sensors be used to monitor the temperature of the energy storage system on the vehicle and prevent the fire in the garage?
Sure. And just to touch on the previous question a little bit, I mentioned the International Fire Code here. I think anytime you're starting off into a project, your adopted codes and standards might be a cycle or two behind. Whenever you're writing an RFP, I would highly recommend including prescriptively the use of the most current fire codes. It's like we see the 2024 IFC, the International Fire Code, starting to try and take a swing at how to at least apply the rules for lithium ion storage as it relates to vehicles. So that's going to continue to progress. But if you're adopting code cycles that are 1 or 2 code cycles behind, you're really not working based on the best information and applying those requirements that the committees have been working on over, with code cycles since the adopted standard. So then to the second question there, we have looked at using infrared. There is potentially a space for it. I lean towards smoke detection because it's usually a little bit more familiar to facility operators. A lot of it depends on how you do your maintenance. You might have facility maintenance individuals that are more familiar with smoke detection, and then you want to kind of lean mitigations to something that's more familiar. If you start coming up with novel solutions to every problem, then it can become an issue to maintain, where if something works great in the first 5 years, but no one knows how to take care of it, or the one person that was trained then retires, and you start losing the ability to be able to maintain those systems and keep them operational. So infrared, I think, will have a potential, especially when you look at it throughout the entire parking garage or storage facility, especially if you're doing a transition from CNG or diesel buses to electric buses. I feel like there's going to be a fair amount of noise there to figure out what is an actual event, to be able to catch it early enough to make any kind of appreciable difference. And you're also probably going to be seeing smoke detection or smoke emitting from the bus around the same time. You're going to see that appreciable level of infrared increase. So not that it's a non-starter. I just think that it's going to be a little bit harder to integrate than what we would see with a smoke detection system that we normally integrate into fire alarm systems. And then also, will it perform that much better than a smoke detection system? That's the balance to play with, each individual situation to see if that's a technology that people are used to. Then I think it's a lot more viable to look that way.
Great. And I won't let you go just yet, Chris. You're popular here with the fire topic. So one more question for you. Is anyone differentiating fire risk by battery chemistry, or is any lithium-ion battery treated the same way?
Yeah, they are starting to see testing now, the different battery chemistries, especially different battery chemistries becoming less susceptible to thermal runaway. There are trade-offs with each one of them, though. So each chemistry, while it might be less susceptible to thermal runaway, it might also have more toxic off-gassing, or it might have more of an explosive, risk to it. So I think that will also continue. That's going to be hard for all of the jurisdiction or all of the code committees to keep up with, because there is, any OEM they can foresee there's no reason to keep them from being able to try out different chemistries to improve their performance. So then we're always going to be kind of backtracking against it. So a lot of the studies and the research, you start seeing whether they're, the risk associated with each one of them. As that starts getting more solidified, I think we'll start seeing that built into the codes more explicitly.
Perfect. All right. It looks like we are Pretty much at the end, I'll let this one more question that just came in get in under the wire before we close out here. And this is either for you or for Amin. Any guidance on parking or charging an electric bus near a conventional diesel fleet? And should the BEVs be kept in different zones?
Amin, you want to take that one?
Yeah, so for one of our projects, we did park the BEVs close to the the diesel buses. It's currently under construction, so I wouldn't have an answer yet. But I've seen many RFPs where the intention is to have the BEVs close to the normal diesel buses. What's going to happen if we don't take some of the precautions is that we are going to lose all of our fleet, if that is going to be the case. Now, sorry, I have another question that came in from one of my dear friends, and the question was, are there any, and that's for Chris, are there any alternative solutions beyond sprinklers?
So when recommending fire protection approaches, we like to try and keep it as straightforward as possible and stick with what is known. So suppression, fire sprinklers have been used for more than 100 years. We know they're effective. They're already planned to be in most facilities. It's whenever you start to get in, especially into retrofits, it's going to be difficult in a lot of scenarios when you're converting and trying to increase the sprinkler system. That's when you really have to start playing the cost benefit scenario of whether sprinklers are the best means of being able to control. If to be able to provide adequate water demand based on the analysis, you need to install a water tower. That's a different conversation. And then that you start looking at other opportunities of being able to provide different levels of mitigation to be able to control and get the event before it gets too far out of hand. So large volume spaces like this are difficult environments. Foam systems, we've seen that they've not necessarily held up well to be able to extinguish these events. It's similar to what you would put into like an aircraft hangar. I think as you start looking into additives, they start getting costly very quickly. So I think my first approach is always to look at, will sprinklers work and what level of sprinklers are needed? And then if for whatever reason, due to water supply issues, pressure issues, whatever it may be, you start working that backwards. If that does not work, then do you look at doing some kind of passive barriers and start being able to isolate into a smaller zone to protect in a different way? So right now, sprinklers are the best means of being able to control and put enough water, not necessarily only on the affected bus, but then cooling the adjacent assets so that they don't then become don't have one bus fire that turns into a 2-bus fire to a 3-bus fire. So, but starting off with that as your benchmark is what are known means of controlling a fire event, and then working back from there to figure out what the best arrangement is for each facility is, I think, the best way to start at each process.
Fantastic. Thank you so much. It does look like we are out of time for today, but we really appreciate all the questions. And if we were not able to get to your question, definitely happy to follow up with you after the call. Thanks again to everyone who attended, and a huge thank you to all of our speakers, and again to Opta as well. We hope you found this valuable. Definitely check us out at betterfleet.com and at aecom.com. And I hope that everybody has a great rest of your day. Thank you so much.
Appreciate it.
Thank you.